What if I told you there's a way to write code where bugs basically stop happening? No hiding states, no weird side effects, no why did this variable change moment at 2 a.m. Sounds fake, right? But this is exactly the promise behind something called functional programming. And it's not new. In fact, it's older than most programming language you use today. I'm Yukari Esther, and this is Neural Bloom, where we make complex technology actually understandable. So, if that sounds interesting to you, consider subscribing and leaving a like. It really helps the channel grow. And if you'd like to directly support future videos, you can also support me on Buy Me a Coffee. So, with that said, let's dive into it. Most of us learn programming like this. You create variables, you change them, you run loops, you update stuff over time. Basically, you're telling the computer, hey, do this, then change that, then modify this again. This style is called imperative programming, but functional programming flips this completely. Instead of telling the computer how to do things, you focus on what the result should be. Let's break this down with something familiar: cooking. In traditional programming, you're like a chaotic chief. You grab ingredients, you change them, you taste and adjust. You reuse the same bowl for everything. Same point, the kitchen is a mess. And you don't even remember what you changed anymore. Now enter functional programming. Here, every function is like a perfect recipe. Same ingredients, same result. No touching other dishes, no changing the original ingredients. If you follow the recipe twice, you get the exact same dish every single time. No surprises. This brings us the heart of functional programming: pure functions. A pure function, it's simple. Same input, same output, no side effects. That means it doesn't change external variables. It doesn't depend on hidden data. It doesn't mess with anything outside itself. Think of it like a math function. 2 plus 2, it's always 4. It never suddenly becomes 5 because of something else in your code. Here's something cool. Functional programming concepts come from mathematics, specifically something called lambda calculus, created in 1930s. So yeah, this idea existed before computers were even common. Next concept, immutability. Big word, simple idea. Once something is created, it doesn't change. Instead of modifying data, you create new data. So instead of change this list, you do create a new list with the change. At first, this sounds inefficient. Like, why copy everything? But here's the twist. It makes your code predictable. No random changes, no hidden mutations, no who touched this variable. In functional programming, functions are treated like Lego pieces. You don't build giant, messy blocks. You build small, clean pieces and combine them. Example mindset. One function filters data, another transforms it, another combines results. Each one does one thing well. That you chain them together. Simple, clean, powerful. So why should you care? Because functional programming helps you. Write more predictable code. Avoid hiding bugs. Make testing code easier. Scale system better. This is why companies dealing with massive data, like in machine learning pipelines, often lean heavily on functional concepts. Here's the funny part. You're probably already using functional programming, even if you don't realize it. Ever use map, filter, reduce? That's functional programming, skinning into your code, quietly making things better. Let's quickly recap. Functional programming focuses on what, not how. It uses pure functions, same input, same output. It avoids changes with immutability. It builds systems using small reusable functions. In short, less chaos, more clarity. Now I'm curious, do you prefer writing code that changes everything, or code that stays predictable and clean? Drop a comment below. Functional or imperative? Which one do you lean towards? And if you want more videos breaking down complex tech ideas in simple ways, hit like, subscribe, and see you in the next one. Bye!